Hello, everyone. Welcome back to the AAS YouTube channel. And this one is going to be the start of something new. This is going to be a wind up to the joint AAS 236, the American Astronomical Society 236. And it's also in combination with the Laboratory Astrophysics Division, LAD division meeting. And so we're going to start introducing some of these people in LAD to the AAS 236 community. And I'm super happy today to have Murthy Gudipati with us. Hi, Murthy.
Hey, I'm really excited, and also we are looking forward for the first ever virtual meeting that's going to happen.
Yeah, it'll be historic, actually.
Yeah.
Who knows, you know, we may actually find that we like these virtual meetings better because we don't have to travel, we reduce our carbon footprints, etc. Yeah. We may actually find we like it better. I'm not going to say too much, but I will say for a summer meeting, the registration is way up.
Yeah, we have a fantastic registration, actually. Also, abstracts.
Pretty good show.
Yeah.
So where are you at right now?
I'm at the Jet Propulsion Laboratory, California Institute of Technology. It's a part of NASA. So we are FFRDC, and I'm at the Science Division. Sorry for all these, bells that are ringing in the back with the emails and all the stuff like that. Yeah, I am at JPL in the Science Division. And we have science and engineering, as you know, and we do research in a laboratory that is related almost to every aspect of astrophysics and planetary sciences.
Cool. I imagine you guys are shut down right about now because of the pandemic.
Yeah, in fact, we were we started very early, teleworking. I started, I think, if I remember right, March 13th, because that was an RDO, and then the weekend, and then Monday came. They said you can opt to work at home. On Tuesday came, and it became a mandatory work at home. So it was really a good decision to have. Send people to work at home, because it's a lot of change that you have to, I was working on almost for 2 weeks to make my, let's say, once in a while used office into almost 24/7 office.
Yeah.
and I used to joke to people on telecoms that once we are done with this, we are really halfway through being trained as astronauts, because we work in 6x6, almost like space.
Be careful what you wish for; they might put you on the next one.
That's fine. Yeah. And also I have my stand bicycle in the back, so that I can once in a while get up and do some exercise rather than sitting in the chair all the time. Yeah,
that's a good thing. Cool. Yeah. So what do you like to do for research?
Actually, profound things are simple. Okay. My research goal is to try to understand the chemical evolution of the universe.
Ooh.
Leading to the origin of life on Earth.
Uh-huh. Cool.
So we still don't know how life started on Earth. I think there is some clue in that we started with gases or elements, and then elements became molecules. Molecules became bigger molecules. So that's what is driving force for me to do research.
Cool. How did you get into that field?
It's a long journey. It's not like a slingshot and one like shooting an arrow. You go straight through what you want to do. But I have been always fascinated by looking at stars and planets, even from my childhood. I spent in small villages in India. Mm-hmm. I used to look at the sky. At the time, I didn't understand what it was. but full of these stars that you didn't have any more space left, in the sky. So that was my fascination. And then as I grew up, I went to college. I learned physics and chemistry, mathematics. This is what I was fascinated definitely by natural sciences than going to, let's say, to economics and other things. Though I was at times asked to do that because that would have given me better job opportunities.
Right.
I said, no, I want to understand nature. Okay. And then later on, when I went to PhD and other things, beyond that, I moved into low temperature physics and chemistry.
Okay.
So low temperature took me to astrophysics and planetary sciences. And that's where I am right now.
Awesome. So what are some of your research projects right now?
So because of my, the background and how I did my, entire, let's say, world tour on this kind of research, my research activity is also really broad. In our lab, we almost try to simulate almost all conditions that are accessible to us.
Okay.
For example, we developed methods to interrogate interstellar ice grains when they are irradiated with UV photons or electrons. We showed that even at 10 Kelvin, you can have the generation of complex organics from simple molecules like water, ammonia, or CO and methanol. That's what is supposed to be interstellar ice grain composition, So
I would imagine the reaction rates get kind of slow at 10K. I mean, they still happen, but
yeah, they may be slow, but we have plenty of time, right?
But you got a lot of time. There you go.
In fact, what we did was, cool thing is to zap up with an infrared laser to ablate the ice and look at the ice, plume composition.
Yeah.
And we found that these molecules, in fact, very closely we published this work as the Rosetta mission was getting its measurements on cometary Cherenkov-Gerasimenko's outgassing. And there were so many molecules that are found in our lab and with the mission, connecting somehow the interior of a comet to the interstellar ice grains. So nice. That's cool. Yeah. Then we also work on Titan atmosphere. We showed that Titan's lower atmosphere is not not boring. There's still photochemical processes going on there. Though the photons going there are much lower than what we get on our Earth. But still, it has its time,
Yeah, you got time. So time will cure a lot of things.
Recently, we started working on also a Europa surface with mega electron volt electron bombardments. And we have also started venturing from all the way cold ices into hot Jupiter-like atmospheres. So we simulate in our laboratory temperatures going up to 1800 Kelvin to understand how aerosols and atmosphere are produced. So yeah, it's pretty.
Well, you sound like a perfect candidate to be the vice chair of the Laboratory Astrophysics Division. What is the Laboratory Astrophysics Division? What is its what does it do? What is its mission? What does it aim to do?
So the Laboratory Astrophysics Division, or let us call it as LAD. That's a nice way of pronouncing it. It is to our goal is to understand the universe through promotion of fundamental theoretical and experimental research in the lab into the underlying processes that drive the cosmos. This is our mission statement that is given on our Laboratory Astrophysics webpage. Essentially, what we LAD does is conduct. LAD members do, not LAD alone. LAD members do is to conduct research that helps understand the phenomena. And the membership could also be not only people who are working in experimental work, but also the observers, and the modelers, because observers see some, let's say, spectra, and they need to be interpreted.
Right.
And so they need to have lab data. And modelers, do modeling, and they need to use lab data in order to feed into their models. And this lab data needs to be refined all the time as our knowledge increases. So LAD is there to bring all these three categories together: the researchers in lab work, in modeling, and in observations.
Cool.
And provide a platform for everyone to improve our understanding.
Yeah, and in fact, just we have an entire corridor in the AAS journals with Laboratory Astrophysics. Chris Lintott heads up that corridor, and Daniel Saban, who we will be talking to in a future video, is one of the primary SEs of the Lab Astro.
Yeah,
I get how old is LAD? I get the impression it's relatively young.
Oh, that's why I said we want to use the acronym LAD as LAD. LAD is still a LAD. It is still a young.
Okay, you got me on that one. Very good. Very good.
I started with LAD much before LAD became LAD.
Oh, wow.
Before that, the AAS has established a working group of laboratory astrophysics in order to, study how we can bring this division into existence. So I was a member of this working group of laboratory astrophysics since 2009.
Oh, okay.
Yeah, and that work culminated in a report that we wrote, and that was accepted by AAS to formally start LAD in 2013.
Wow.
But at that time, I stepped aside, but I kept working with LAD leadership to have, my goal is to bring these communities together.
Yep.
The observational and a modeler, and then the experimental communities, and that I have been doing it by working with LAD leadership and DPS and the EPSC, AAS leadership. And in 2019, yes, I was elected to be the vice chair, and since then I have been in the leadership position with LAD.
How many members are in LAD currently, roughly?
100? I think I may be definitely erroneous on this, but my guess is in our discussions, about 250-ish.
Okay.
Yeah, and my goal is actually to double it in the foreseeable future.
Sure.
Yeah. I think about 500 would be really good to start having its own personality and things like that.
Yeah, and I imagine, maybe people are unaware, but, basically, I think it covers many forms of laboratory observation and theory. So it could be chemical, it could be nuclear, it could be experiments on opacities with, like at Sandia, for example, where they're popping material, or lasers at one of the various laser facilities. So it's got a pretty wide scope. So it could seem like, it's got growth potential, I think.
Yeah, I think we really bridge almost all divisions, whether it is heliophysics, whether it is, plasma physics, or low temperature physics, astrobiology, you can, everything, the lab astro is like a glue that brings, these areas of researches together And it gives both impetus for them to look for, and also the data that is needed to understand what they look for.
Absolutely, definitely. So you're doing LAD and SS are sharing a meeting at 2:36, so you guys are going to get a focus. And I think you did the same thing in 2019. Is that correct?
Yeah, right now, as we discussed, LAD membership is, let's say, nominal. That's still small, so it may not be really a good idea to have LAD's own meetings. Until recently, we have too many meetings all the time, and so. One of the strategy is to have a meeting with AAS in the summer, and that has been going on for a long time, actually, since its inception.
Oh, okay.
Yeah, since its inception, 2013, we have been having regular meetings with the summer, summer meetings of AAS, and we also have. Joint sessions with DPS and EPSC. Moving forward, I think it would be good. My thinking is that we should have joint meetings with every division of AAS so that we know what that division is working and what kind of members, research activities they are, and how the research activities of LAD members are, can be complemented to bring collaboration, nurture collaboration between these complementary, areas.
Sure. Another one to consider is doing something with HEAD, right?
Yeah, exactly. Yeah. Head is really, would be fantastic. And I have been working, talking to DPS folks also to have a DPS LAD. So it would be good if we move towards that kind of, joint meetings rather than have individual meetings. What happens is too many meetings dilutes the attention of our community.
Right.
And so that would be good. I would really like to see that we have joint meetings with different, AAS divisions. That would be really nice.
Cool. So if I was a graduate student, or if I was a young postdoc, wait a minute, young, I am a postdoc. Why should I join? Let me, what's in it for me? Why should I join LAD if I was a young up and coming researcher?
We have, let's say, we have been working on this statement, why LAD? Probably, it is, as I said, this is a vibrant and diverse community, okay? And by being a member of LAD, you grow your network with experimentalists and theorists and observers, that is, you are embedded in this community in order to be able to draw resources out of it, okay? And that is not an easy thing to do if you are not in the community. Okay.
Right, and at some point you will, if you're a graduate student, you'll move on to a postdoc. If you're a postdoc, you'll move on to other positions, and so it gives you that that backbone, that network of people that can help you in your next steps.
Not only that, in addition to that, if you're a member of LAD, you know whom to go to if you're an observer or a modeler. That I don't understand this. Present models don't work, and we have these observations that are not explainable. Do you think that you can give us some lab data? And that is the beginning of collaboration.
Right. So it sparks new research.
Exactly. Yeah. And that's how actually many of my collaborations started. And recently, the most recent one is accidentally with Rachel Smith, who is our present lab secretary. She's an observational side, and then 5-6 years ago, she discussed with me some ideas that she's not able to understand. I said, okay, why don't we write a proposal? And then it was denied for 3 times, and 4th time we got funding. So.
Very good. Very good. And for those who are interested, you'll get a chance to meet Rachel in a couple videos or so. We're going to be doing one with Rachel.
So for the early career people, colleagues of the astrophysics and planetary science community, what I would like to say is that becoming a member of LAD gives you access to interact with these people, so that you can directly talk to them. You can express, actually I got some students coming to me and said that they wanted to work with me in the lab because they got to know me through LAD or the previous work we did. So it opens up and expands your opportunities.
Yeah.
And for those well-established researchers, if you think that you need some lab data, become a member of LAD, because then you have access to all these people. As simple as that.
Does LAD have? Is there a membership fee?
I think there is. AAS, if you are already a member of AAS, lab membership fee is very nominal.
Yeah.
And also you can become an affiliate of LAD, but membership fee is so small that it should not be a showstopper.
That was my point. It'll be the best $10 you ever invested.
Yeah, exactly. Exactly.
I wasn't trying to get, it's really expensive. No, I was trying to go the other way.
It's absolutely, it's very nominal. One could have made it free, but I think there are certain reasons why we need to have this membership fee in order to do some minimal service.
Network infrastructuring, right? Yeah. I mean, it does cost a little something to build these networks for people to take advantage of them. And so it's really well worth it. So
become a LAD member, you're going to really enjoy. We are nice people here.
Cool. Are you guys going to have a specialized booth at AAS 236?
I'm not sure, but we have a town hall on Monday evening, most likely. Yeah, it would be on the block schedule. We have a town hall, and please mark on your calendar and come there virtually. Yeah.
Okay. I will be in the AAS publishing booth. During the meeting, and so we will. We're going to be trying to giving out some bling, and so we'll try and give out some LAD bling and encourage people to become LAD members and go to the town hall and spin up that community. That'll be great. Let's see. Is there anything else finally you'd like to say about LAD to veteran members since 2013 or to new members?
One thing that comes to mind is we are in a unique position today in terms of astrophysics and planetary sciences. Never before we have been so successfully conducting missions that reached beyond, let's say, almost close to the Big Bang, almost close to the Big Bang, versus and then we have planetary missions that have gone almost beyond our solar system, like the Voyagers. And we have a fleet of explorations, and these explorations not only bring us so much of new information that needs to be converted into knowledge, but also provide us with an opportunity to build new missions in the future. So converting the data that we get into knowledge needs the observers and the modelers and the experimentalists to work together.
Yep.
And then come up with new instruments, new missions that can even take us beyond what we are right now. Look at the mission like New Horizons. It showed us Pluto, which is entirely different than anyone could imagine.
Right.
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 So we have so many such missions. Pluto is one of the New Horizons is one of them.
It has this gooey stuff on the surface.
Yeah, it's nitrogen, it is methane, it is carbon monoxide, and rocky water ice.
Yeah.
You know, this is crazy, and it is somewhere between a solid and a liquid. It's a fluid. It is, you know, there's so much of physics in that, and we have only very little amount of ground truth in our hand.
Yeah.
And so it needs a lot more scientists, especially the younger generation, early career scientists, to take up this laboratory research so that there can be rigorous and proven lab ground truth for us to understand various kinds of phenomena in our solar system, beyond our solar system, in the exoplanets, in the protoplanetary disks, you know, and even in the interstellar medium. So there's a lot of opportunity here.
Cool.
Yeah.
That is awesome. All right. There's the pitch. People join LAD. It'll be great. Murthy, I want to thank you so much for your time this afternoon. I really appreciate you spending a little time with me and chatting.
Thank you, Francis, and asking for this. It was almost spontaneous, so it's really nice to to have this conversation. Thanks again for.
You're welcome.
Yeah.
Also, just demystifies a little bit. All right, everyone. Thank you so much, and we will see you on the next LAD video. Thanks. Bye-bye.